Hello, I'm Patty Simpson with Simpson Math. Let's talk about the mean. The mean is what most people think of when I say the word average. So if I ask you, what's your average in your class, you would typically give me the mean as your answer. So the mean is just what is typically thought of as the average. So what do I mean by that? Well, I'm going to give you a scenario here. Let's say that we have, it's the apocalypse, and all of a sudden the whole world is crumbled and we're looking for food. And three of us run into a dorm and search the dorm for food. And the first person comes out with a stack of food here. They have 1, 2, 3, 4, 5, 6, 7 packets of ramen noodle. So the first person has 7 packets of ramen noodle. And then the second one runs into the dorm and searches the dorm. And they run out with, let's count and see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 packets of ramen noodles. And then the last person runs out with 1, 2, 3, 4, 5, 6 packets of ramen noodles. So we have 7, 11, and 6. And the 3 people decide they want to split the ramen noodles evenly. They want to have an average. Everybody get an average number of, or a mean of these ramen noodles. So they want to split them evenly. So, you know, if we give this one a couple over here, and we give that one over there, so that everybody has the same number of ramen noodles. That is finding the mean. That's really what we're doing when we're finding the mean. We're taking all of the ramen noodles and splitting them up evenly. And that's what that mean is. So in this case, our mean should end up being 1, 2, 3, 4, 5, 6, 7, 8. Everyone ended up with 8 ramen noodle packets. Maybe when you've thought of the mean in the past, you've been taught to add the numbers. So when I add 7 plus 11 plus 6, so that I'm getting all of the ramen noodles, seeing how many there are all together. When I add that, I have 18 plus 6, which gives me 24. And then I'm going to split it into 3 equal groups. So then you divide it by the number of groups you want, or by the number of people there were, or the number of numbers you have, so that you get 8 in each group. Maybe you've just been taught to add and divide by the number. This is what you are doing. You are sharing them equally. That number that you found, the mean, is an average, and it's a statistic if your data set comes from a sample. But if your data set comes from the entire population, we call that mean a parameter. So depending on if that's, you know, you're a sample of the world left, or you're the whole population, the whole group of interest, then you're a parameter. I'm going to give you a big fancy mathematical formula to show exactly this, to show that we've just added the numbers together and then divided by however many we have. And that big fancy formula looks like this. We use this capital letter sigma to mean summation. It means we're going to add up all our numbers. And we call those data values. These are our x values. They're our variables. So in this case, we have 3 different x values. Our x values are 7, 11, and 6, and we added them all up. So I'm going to show that. I'm adding up all my x values. Now, in order to differentiate between the 3 of them, you know, there's 3 x values. To differentiate between them, a lot of times we'll put another little variable down here called I. And I just says, well, he's the first one, he's the second one, he's the third one. So, you know, the first x would be x of 1. The second x would be x of 2. And I would just mean that 11 there. So this big fancy thing just says I add up all my x values and then I divide by the number within my group. Now, remember from before, when we use that capital N, it means that we have a population size. And to show that this is the mean, we use a Greek letter mu, this Greek letter mu, to mean the mean of a population. If I only get a sample, the formula is exactly the same. We add up all our variable numbers, all the numbers in our data set, and then we divide by the sample size. In other words, we still divide by however many numbers we have. It's just our notation looks different. We use X bar when we have a sample. So this is for the sample mean. So we would be finding a statistic. And this one is for the parameter mean, or the population mean. So we would be finding a parameter. I should really make that population mean so that we're finding the parameter. Population mean, so we're finding a parameter, and here we have found a statistic. It's one number to represent all of my data. So big fancy formula that just says we add up all our numbers and divide by however many numbers we have. So let's do another example. Let's say that I have a dot plot that shows the hours employees worked. So we have this dot plot here that we have a bunch of part-time students that are working for us. And so we've got a dot plot that just shows how many hours they've worked. And I'm going to use X's for my dot plot here. But here's my dot plot. So first of all, these are the hours that those employees worked. And we want to know what's the average number of hours an employee worked. Well, I could do that same sharing technique, although sometimes it doesn't turn out quite as pretty as this did. We could use that same sharing technique, or we could just add up our data values and divide by the number we have. So let's add up our data values. Remember that each one of these dots represents a data value. This represents the number 1. This is 4 twice. This is 5. There's 7 twice. And that's 8 4 times. And I'm dividing by the number in my sample set or in my population, depending on if that's a sample or a population. And so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people that worked there. We'll claim this is a population and use the letter mu, but maybe if it were a sample, I would use that X bar. Now I just add up along the top. So I have 1 plus 8 plus 5 plus 14 plus 24. And if I add that all up, it adds up to be 52. Divide that by 10, and it turns out that on average, my employees worked 5.2 hours a week, or 5.2 hours for whatever it was we collected the data on. So that is my mean average. That's the mean of that average. Notice that when I'm talking about the mean and I'm finding the mean, I have to have quantitative data. My data in both of these situations are numbers. They're numerical values. They're numerical measurements or counts. So in order to find the mean, we have to have quantitative data. So let me write that down for you. For the mean, we find the mean with quantitative data. In other words, when you think about your levels of measurement for your variable has to be at least interval. We can only find the mean with interval or ratio levels of measurement. I can't find the mean of qualitative data. I can't take brown, black, blue, color of eyes and add that together and divide. It just doesn't make sense to divide those words. And the same thing is true even when I have something like a Likert scale. Because remember that that Likert scale is just qualitative data. So while I may be giving you a number that, you know, at the doctor's office, I may say my pain is 4. Really what that means is I'm in a little bit of pain. I can't add that up and divide by some number to find the mean. So to find the mean as a statistic or a parameter, we need to have quantitative data. It needs to be in the interval or ratio level of measurement. Then also notice that this 5.2 is not part of my data set. When I wrote down my numbers, 1, 4, 5, 7, and 8, nobody in that data set worked 5.2 hours. And yet my mean ended up being 5.2. It was the same with my ramen noodles. One person found 7, another 11, and another 6, and yet each of us shared 8 packets of ramen noodles. So that 8 was not a measurement in my original data set. So the mean is not necessarily, the mean is not always a number in the number set. And one last characteristic of a mean is that every data value affects the mean. So every single number, whether it's the 1 or the 8, every single number in our data set affects the mean. So that mean is what we typically think of as our average. And to find it, we just add up all the numbers and divide by however many values we have in our data set. Math Made Simple, it's Simpson Math. Thanks for watching.